This is exercise 11H on volume of rectangular prisms on page 663 of your textbook. Now, where would we use volume? So where would we care about volume in our everyday lives? Yeah.
For example, if we're making a big pool and you need to know how much water to fill.
Yeah, if you're filling up a pool, right, of course, so anything to do with liquid, where else would you care about volume? When you go shopping, what are you looking for? What might be found in volumes? Yeah. Yeah, Georgina?
Like volume is in food as well because you'll pretty much get, because some shops actually have the volume actually have L or ML.
Good. So it's in form of capacity, right? So for example, when you're buying soft drink, how big is a large bottle of soft drink? Oh, it's 1 point, sometimes 1.5, sometimes 1.25 liters. How big is a can of Coke? 375, very close, right? So knowing the volume allows us to be able to compare sizes. A lot of the time, have you guys ever bought like a bottle or like a big bottle of soft drink or whatever it is, and then you realize as you're pouring it out, it feels a lot less than it actually looks like? A lot of marketing involves trying to get you to look at a bottle and think that's quite a big bottle, when in reality it's not that big of a bottle. So understanding volume is very important in real life because you don't want to get scammed, do you? So volume, if we're looking at by definition, is the amount of space inside a 3D object. So before, we're looking at area, which is found in the 2D object, whereas volume is in a 3D object. And it's measured in cubic units. Of course, with area, we're looking at squared units because we're looking at little squares. But now we're looking at cubes, so cubic units. I've included a couple of examples just so you can see over here. Cubic millimeters is a 1 by 1 by 1 millimeter cube. Makes sense. A cubic centimeter, same thing, but 1 by 1 by 1 centimeter. And you can imagine, of course, 1 by 1 by 1 meter. It's going to give us meters cubed. We're used to converting, for example, let's say, if I'm converting 10 centimeters into millimeters, we can just times by 10. But I do want to note, now we won't cover this year, but the conversion from distance, for example, centimeters to millimeters, is different from, for example, area, so millimeters squared to centimeters squared, or millimeters cubed to centimeters cubed. So it's different. You're not going to be assessing that this year, but just keep that in mind. Okay, so the formula for rectangular prism, can I get you guys to copy down just the part that I'm highlighting now? Volume of a rectangular prism is given by the formula where we have length times width times height. Length times width times height, or LWH. Another name for rectangular prism is a cuboid, just giving you guys a heads up. An interesting fact, just like how a square is technically a rectangle, a cube is technically a rectangular prism. Technically. No one calls it that, but technically speaking. Okay, so length times width times height. The formula is quite straightforward, and it makes sense. Because if you imagine if we were finding the area of the base, and we multiplied by the height, it's kind of just like a normal rectangular formula, except with another dimension. Now, of course, the same thing applies for our cube. Because with a cube, right, let's go back to the idea of a square. A square is the same side length, doesn't it? So we said that the area is length times length, or length times width, which is the same thing, length squared. In this case, the volume of the cube can also be found by using length times length times length, which is just length cubed, which is the same thing as our formula anyway. Very quickly, we're just going to go through two examples. The idea of a rectangular prism is quite easy to find the volume. All we need to do is multiply our lengths here. So we've got an example right here. Find the volume of the rectangular prism. In this case, of course, I know my length. Now, you don't need to write this out every time, just for our project. So length equals to 8 cm. Our width equals to 3 cm, because that's that depth there. And then finally, my height is equal to 4 centimeters, and that's that height right there. Can you guys see that up the back? Yep, okay. So we end up with that. We use the formula, volume equals to length times width times height. So that's 8 times by 3 times by 4, which I know gives me 96. Is that correct? Yep, 96. Am I done? Henry. Good. What units are we using? We're using centimeters, right? And then, as you mentioned, we cube it because it's volume. So anything in a 3D space, like volume, has to be cubed. Anything in 2D space has to be squared. And of course, if it's in a one-dimensional space, so for example, it's just millimeters, then we don't need any power. Technically, it's 1, but we don't need it. Okay. Next example, same thing. I'm not going to bother writing out all the working out. I'm just going to show you what we can do to easily find it. All I need to do is write volume equals 2, and then write the numbers next to each other. 6 times 4 times 2. I know 6 times 4 is 24. Times by 2 is 48. And remember, our units, in this case it's centimeters again. Centimeters cubed. Thank you very much. Okay. So the idea of a rectangular prism is pretty straightforward. If you're presented with cubes that are, for example, 1 centimeter by 1 centimeter by 1 centimeter, you can just count up how many cubes there are. So the same idea, but this is what happens if you've been given measurements, not particularly cubes. Any questions? Sweet.